Okay, hello everyone. So in this video I'm going to teach you how to solve a problem that asks you to plot an input voltage versus an output voltage versus an input voltage in some circuit that has some diodes, whether the number of diodes is 1, 2 or 3 or any number of diodes. In this particular example, this is the circuit and we have only 2 diodes. And what we're going to assume is that the two diodes that we are going to consider are ideal diodes, which means that it's an ideal model, which means that the diode is either considered on or considered off, depending on the voltage difference between the P and the N. If the voltage difference is in favor of the P, which means that the VP is larger than the VN, okay, in that case it's on, otherwise it's off. Okay? So let's have a look here at this example. So what do we see? We see that V input is an input voltage that is controlled by the user, and it increases as determined by the user, and the output voltage depends on the input voltage. So in order to solve this example, we want to see what is the value of V input that is extremely small, okay, in order for us to calculate to see these two diodes. So what I'm going to do is put V input very, very small, close to negative infinity. And what I do care about in this particular circuit is negative 20, because it's the smallest value that I have. So I'm going to put V input as small as possible, okay? And thus what I care about is that it is smaller than the smallest value in the circuit, which is negative 20, as opposed to positive 10 volts at the top. Okay? So at this particular instant, when V input is negative 20 volts, is less than negative 20 volts, is much less than negative 20 volts, you expect that this voltage value is going to be negative, and thus these two diodes are going to be one of them is going to be reverse and one of them is going to be forward. How am I going to do this? If this is negative, let's say negative 30, okay? Negative 30 means that this value is negative, okay, compared to this value, which means that it falls under this case, which means that this is off. So this is why I'm going to draw the circuit again and consider that D1 is off. It is reverse bias. And when this is negative 30, then you expect that this diode is on. Why? Because negative 20 is higher than negative 30. And this is why diode 2 is on. And that's why I need to draw it as a short circuit. So when this is a short circuit, so what do you expect that the output voltage is going to be? Let's solve for KVL in this loop. Okay? What does KVL says? Let's assume that this is current I, okay? And since this current is following this direction, so the voltage drop is in that direction, okay? And the same goes here, so that's the voltage drop. So what does KVL says? What does it say? It says that V input plus I multiplied by 1K, okay, 1 kilo ohm, okay. Is it a plus or minus? No, that's a minus, because the direction of the voltage is opposite to the direction of this voltage, so it's a minus, okay, minus I, and then minus let's see here, that's the output, minus I multiplied by 1 kilo ohm. And then here, minus 20 volts equals 0. Okay? Which means that V input equals I multiplied by, let's see, so that's 2 kilo ohms. Okay? So that's 2. So that is 3 kilo ohms. Okay? Plus 20. So I equals V input minus 20 over 3. Okay? Why did I consider this as minus 20? Because I could replace this negative 20 volts by a battery here, minus plus 20 volts. Okay? Which means that it should add up. It should be, so if you take this loop, it should be at least 20, it should be added to the V input. So it's a plus. So this is a minus, so that's a plus. Okay? Again, if you take this, the KVL in this loop, and define the voltages, you end up having this equation, which is I equals V input plus 20 over 30, over 3. Okay? So let's see what the voltage of the output is. V output equals minus 20 plus I multiplied by 2 kilo ohms, which is equal to negative 20 plus V input, that's the I, plus 20 over 3. So that is multiplied by 2, which is equal to negative 2 over 3 minus 20 plus V input over 3 plus 40 over 3. Okay? 40 over 3. Okay? So that is a total of V input over 3 minus 60 minus 320 over 3. So that is the value of V output in terms of V input. Okay? And this is the first equation. Okay? And that's when V input is extremely small. Okay, then you sweep it to the next level. Let's increase the V input voltage to a value between negative 20 and the successor and the value after that, which is 10 volts. So something between negative 20 and 10 volts. Okay? So I'm not going to erase this equation because that's all what I need from this regime. Okay? And then I'm going to put here V input lies between negative 20 and 10 volts. Okay? In that case, you expect that this is still going to be reversed, but this is going to be a forward bias. Okay? Which means that this is going to be reversed and this is going to be a reverse bias, which means that this is going to be an open circuit. Okay? Which means that V input is equal to, V output is equal to V input. Okay? So that's the case when V input is very small, okay, is less than or equal to negative 20. Whether you put equal or not doesn't really matter, okay? And this is when V input is very large. So let's write it down here. V output equals to V input over 3 minus 20 over 3. V input over 3 minus 20 over 3. When V input is smaller than negative 20. Okay, and then V input when it is between 10 and negative 20. Okay, and then we want to see what the value of V output when V input is larger than 10 volts. Okay? So when it is larger than 10 volts, what is the value in that case? You expect that this is going to be forward and this is still reverse. So you expect to see here a short circuit and this is a reverse, which means that let's erase this, plus minus, okay, and this is 10 volts, which means that I have a battery here connected to 10 volts, okay, current is passing this direction, so the voltage is here, positive, so the current passes here, the voltage is like that, okay, so the voltage is opposite to the current, okay, and let's put KVL, that is 10 volts, KVL in this loop, V input minus I, so that's the voltage, okay, the voltage in this direction, the voltage in that direction, so it's minus 1 kilo ohms minus 1 kilo ohms multiplied by I, okay, and then minus 10 volts equals 0. So V input, which ends up with I equals V input minus 10 over 2. V input over 2 minus 5. Okay? So the value of V output, which is this value, okay? So you can take, so that's the output. So I'm going to take KVL in this loop. So end up with V input minus I multiplied by 1K minus V output equals 0. So V output equals V input minus, what is the value of the I? V input over 2 minus 5 multiplied by 1K. So V input over 2 minus, so that's plus 5. Okay? So that is the value of V output. Alright? V input over 2 minus plus 5. Okay? So let's plot these equations. So what's the first equation? Okay, so these are the three equations. That's when V input is less than negative 20 volts. That's when V input is between 10 and negative 20. And that is the last one when V input is greater than 10 volts. Okay? So recall that there was a typo here at the first equation, which is this 2. Okay? So I forgot to write down this 2. It's exactly at the minute 6 minutes and 40 seconds. So I forgot to write down this 2. If you want to calculate this first equation, you can. There's an easier way to write it down. To write down this equation, which is using Kirchhoff's current law. Okay. So in order to deduce this equation, we assume that the first diode is that this diode is on while the other one is off, is not conducting. Okay. And in that case, you could write down KCL at this node. There are two currents, one passing this in this direction and one passing in that direction. Okay, and thus the voltage, since the current passes from top to down, then the voltage is in the opposite direction, and the voltage here is in the opposite direction as well. The positive is at the head of the arrow. Okay, and that's the positive as well. That's the voltage. That's the polarity of the voltage. Okay. If you want to write down KCL, so you write down the equation of the currents that come into the node, which is this current, equal the currents that come out of this node, which is that current. What's the value of this current? It's the potential difference over the value of the resistor. V input minus V node. V plus minus the V minus over 1K equals V output minus negative 10 volts over, I know that was 20 volts, okay, over 2K, okay, and then, so that's V plus minus V minus over the potential difference, okay, then this becomes V output, you do the math, becomes V output 2VO over 3 minus 20 over 3. Okay? This way is KCL. If you were not able to do it using KVL, that I have done it, that I've used in the first time. Okay? So that's KCL. All right. So right now we have three equations. The first one. Okay. So these are the three equations, and we want to plot them. The first one is 2V input minus 20 all over 3. So when you put V input equals negative 20, okay, so we want to find the value at this axis, okay, then V output becomes 22 multiplied by 20 with a negative sign, and then negative over 3, which becomes 3 volts. Which becomes 20 volts, the negative. Okay, so that is negative 20, okay, and that's the point that we're looking for. And the slope is 2 over 3. 2 over 3 means that it is something like this, okay? Okay, so that's 2 over 3. Okay, or you can write it down 2 over 3. Okay, so that's the first part of the curve. The second part is from negative 20 to 10 volts, which is in this range. V output equals to V input. Okay, then you expect that the slope is steeper. The slope is 1 here, is greater than 2 over 3. The slope is steeper. Then you expect the slope is steeper. Okay, so perhaps if it's not really clear, then you could do like this. Okay, then you could do like that. Okay, and then and then it continues till the 10 volts, okay, and then it hits the 10 axis at 10 volts, okay, so that's the second part of the curve. And then finally V input over 2 plus 5, when V input is 10 volts, then V output equals 10 as well, okay, so it's continuous here, and then you expect that this is a point, and the slope is half. Half means that it is even less steep. Okay? Okay? So that's half, and that is 2 over 3, and that's slope is 1. Okay? And this becomes the curve of the input-output characteristics of this circuit. Okay? So if you guys have any questions, please let me know. Right?